Welcome to another chemistry video. Yay! All right, so today we're going to learn about this process called spectroscopy. So this is similar to what we did all the way back right at the beginning when we talked about spectroscopy in terms of the emission spectra of an element as a way of identifying them. So to begin with, here is our dot point. We've got 2 dot points normally for spectroscopy. We talk about the use of colorimetry and or the UV visible spectroscopy, which is what we're going to be talking about this year. And normally we would also talk to you about another form of spectroscopy called AAS, which is atomic absorption spectroscopy, but we've decided because it's not as relevant to Unit 3-4 that we were going to cut that from this year's special COVID course. Yay! So to begin with, we need to focus on light. And we're going to go just through a bit of physics and talk about this thing called the electromagnetic spectrum. So the electromagnetic spectrum has got to do with all light. All light exists on this spectrum. So you can see right down on the left, you can see the gamma rays here. These ones here have a very, very high frequency and a very, very short wavelength. So this is high frequency, and very, very low wavelength. Okay, so wavelength, I know I've done them the wrong way around because they should be opposites. And the symbol for wavelength is like a little Y symbol there. Upside down Y is more accurate. So reading through your notes, it says light is a form of energy which is radiated out from the sun in the forms of vibrating electric and magnetic fields. So this radiation is termed electromagnetic radiation. One way to think of light, or the light that comes down from the sun, is that it's composed of a big complex mixture of all of these waves that we're looking at here. So white light, so the stuff that we see that comes from the sun, is composed of many different wavelengths. So this here is what we call our visible part of the electromagnetic spectrum. And all of those different wavelengths, the colors of the rainbow, when you mix them together, they appear white. So each wavelength of light that makes up this kind of spectrum, each wavelength corresponds to a particular color. When we pass light through a prism or through a raindrop, it splits those wavelengths. The light is split up to its component wavelengths, and each is refracted or bent to a different extent as it passes through the prism. So substances can absorb and emit different wavelengths of light. And what we can do is we can use that to identify a few things. We can do qualitative observations, so what type of element it is we're looking at. We can also do quantitative observations as to how much pigment is there. So thinking about this, the only thing I want you to take away here is that white light is made up of many different colors, many different wavelengths of light. Different substances will absorb different wavelengths of light and then emit different wavelengths of light. And we can use that to do chemistry. So what do we mean by absorbing or emitting energy? Now, this is revision all the way back to the beginning of Unit 1. So it's got to do with the electrons. If you remember that electrons exist at particular energy levels, and when you give them energy, so energy say from light, then you're able to excite them and move them up an energy level. And when they lose that energy or they can't stay excited anymore, they emit that energy and fall back down into ground state. So electrons are in an uncharged state, electrons in an uncharged stable molecule. So we are in a new page now. It says absorbing, emitting energy as the title. So electrons in an uncharged stable molecule are considered to be in ground state. However, when a substance can absorb energy, which causes those electrons to become excited. So in their excited state, they jump from ground state up to a higher energy shell or a higher energy level. However, this is unstable, hence they emit or release the absorbed energy in the form of what we call a photon. So light energy exists as photons as they return to their original stable shell. So here is a little statement. It says the energy absorbed is equal to the difference between the higher So the energy here is equal to the difference between the higher and lower energy electron shells. Hence, each jump that they do is unique. And each energy packet or each photon that is absorbed and emitted is unique. So it just depends on what type of light energy you give them as to how many jumps they make or how high a jump they make, and therefore how much energy they're absorbing and then how much energy they're emitting. So here is that statement. The energy absorbed is equal to the difference between the higher and the lower energy electron shells. Hence, each jump is unique. Each energy packet photon absorbed is emitted and unique. And that's the end of our intro.